The mole concept is essential because it allows chemists to count and compare vast numbers of atoms and molecules. It serves as a bridge between the atomic and molecular scale and the macroscopic world we can measure. Today, we're diving deep into a concept that's fundamental to understanding the quantities of matter, the concept of mole. Let's get started. So, what exactly is a mole? In chemistry, a mole is not a furry creature, it's a unit of measurement. 1 mole of any substance contains Avogadro's number, 6.022 into 10 raised to power 23, of particles. These particles can be atoms, molecules, ions, or any other chemical entity. Avogadro's number. The key to counting atoms and molecules. Avogadro's number, 6.022 into 10 raised to power 23, represents the number of particles in 1 mole of a substance, be it atoms, molecules, or ions. Avogadro's number is a fundamental constant, much like the dozen in everyday life represents 12 items. In chemistry, 1 mole represents 6.022 into 10 raised to power 23 items. What is molar mass? Molar mass is the mass of 1 mole of a substance, expressed in grams per mole. It's numerically equal to the atomic or molecular mass in atomic mass units, U. Calculating molar mass. To calculate the molar mass of a compound, add up the atomic masses of all the atoms in the compound, considering their respective subscripts. For example, the molar mass of water, H2O, is calculated as 2 into 1 gram per mole for hydrogen, plus 1 into 16 gram per mole for oxygen, which is equals to 18 gram per mole. Converting between moles, mass, and particles. Moles serve as a bridge between mass, grams, and the number of particles, atoms, molecules. To convert between them, use these equations. 1 moles is equal to mass in gram upon molar mass in gram per mole. 2 moles is equal to number of particles upon Avogadro's number. Practical examples of mole conversions. Example: how many moles are in 36 grams of methane, CH4? To find out the number of moles in 36 grams of methane, use the formula. Moles is equal to mass upon molar mass. By applying this formula to calculate number of moles, we get moles is equal to 36 in gram upon 16 gram per mole, which is equal to 2.25 moles. To calculate the molar mass, sum the atomic masses of all the atoms in the molecule. As we've seen, the molar mass of methane, CH4, is 16. It's just simply adding all the atomic masses of the atoms. In a molecule like carbon has 12 atomic mass and hydrogen has 1 atomic mass but have 4 atoms, so, in case methane, 12 plus 4 is equal to 16. Confusing molar mass and molecular mass. Students might confuse molar mass, mass of 1 mole of a substance, with molecular mass, mass of a molecule or atom. The role of moles in stoichiometry. Stoichiometry is the study of the quantitative relationships in chemical reactions. Moles play a central role in stoichiometry, allowing us to balance chemical equations and make predictions. Balancing chemical equations. When balancing chemical equations, we ensure that the number of atoms of each element is the same on both sides of the equation. Stoichiometry examples involving moles. In the reaction 2H2 plus O2 gives 2H2O as product, you can use moles to determine that 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. We will do some practice questions regarding stoichiometry in this lecture at the end, so make sure you go through all the video. Now let's talk about empirical and molecular formulas. To find empirical formulas, convert moles of elements to whole numbers, representing the simplest ratio of elements in a compound. For molecular formulas, compare the compound's molar mass to the empirical formula. Let's understand these formulas with the help of examples. If you have 0.5 moles of carbon, C, and 1 mole of hydrogen, H, the empirical formula for the compound is CH2. More practice questions at the end of this lecture. Calculating percentage composition. Percentage composition expresses the relative mass of each element in a compound as a percentage of the compound's total mass. Real-world examples of percentage composition. In water, H2O, the percentage composition is calculated by dividing the mass of hydrogen, 2 gram, by the total mass of water, 18 gram, and multiplying by 100 to get the percentage. 2 gram upon 18 gram, multiply by 100, which is equal to 11.11% hydrogen. Using moles to identify limiting reactants. In stoichiometry, moles help identify the limiting reactant, which determines the maximum amount of product formed. Practical applications with examples. If you have 3 moles of hydrogen and 2 moles of oxygen, hydrogen is the limiting reactant, because it runs out first in the balanced reaction. 2H2 plus O2 gives 2H2O. Applications of the mole concept. Pharmaceutical industry. Drug formulation, chemists use the mole concept to calculate precise quantities of reactants needed for drug synthesis. This ensures that medications are produced with consistent quality and effectiveness. Chemical manufacturing. Chemical production, the mole concept is crucial in chemical manufacturing processes. It helps ensure that chemicals and materials are produced in the desired quantities and with minimal waste. Quality control. By understanding moles and stoichiometry, manufacturers can maintain strict quality control standards, ensuring that products meet specific specifications. And many other industries like analytical chemistry, materials science, food and beverage industry, academic and research, etc. Here are a few practice problems related to the mole concept. Solution to these problems is in the comment section. Problem 1. Calculating moles. Calculate the number of moles in 36 grams of methane, CH4. Problem 2. Molar mass calculation. Calculate the molar mass of sulfuric acid, H2SO4. Problem 3. Stoichiometry. In the reaction 2H2 plus O2 gives 2H2O, how many moles of hydrogen gas, H2, are required to completely react with 3 moles of oxygen gas, O2? Problem 4. Empirical formula. A compound contains 0.6 moles of carbon, C, 1.2 moles of hydrogen, H, and 0.4 moles of oxygen, O. Determine the empirical formula of the compound. As we wrap up our exploration of the concept of mole, you've gained a fundamental understanding of this vital concept in chemistry. Moles bridge the gap between the microscopic world of atoms and the practical world of measurements. If you found this video informative, remember to subscribe to Asterisk Classes for more captivating chemistry content.